Yo, we're back. All right, that's question 12. All right, say in the figure at right, f of x and g of x intersect at O and B. All right, the point O, let me see, the point O, oops, oh, the other one. The point O and the point B, right? Okay, so the question A. Show that the coordinate of B is log E2 and 1. So this is the X, this is the Y. So we have to show that the coordinate of B is that. Now, that's very easy since both the function f of x and g of x intersect at coordinate B. So that would mean the coordinate, this B coordinate, if it is true, it will exist at both of the function. That means when you input those two coordinates in both of the function, they will equal. So for example, f of log E2 would equal to 1 and g of log E2 will also equal to 1. Alright, let's just try that and see does it work. So our function is f of x is equal to ex minus 1. Therefore, f of log E2 is equal to e to the power of log E2 minus 1. Right, so now if you actually punch that into the calculator, e to the log E2, and that will just give you 2. And 2 minus 1 is 1. So f of log E2 is equal to 1. So that point exists on that that equation, the f of x equation. Let's see what it does exist on the g of x equation. Alright, so g of x is equal to negative 2 e to the negative x plus 2. Right, so therefore g of log E2 will give us negative 2 e to the power of negative log E2 plus 2. Now if you punch this bit into the calculator, if you punch, I'll just write that here. If you punch this bit into the calculator, you will get, I believe it was half, negative half, I think. Yeah, I think it's negative half. So negative 2 multiplied by negative half plus 2 is equal to, now negative 2 times a half. Oh no, I think it's just a half, not a negative half. It must be. Let me just double check with the calculator. I'm not too good with my log laws. So embarrassing. This is negative ln 2. Give you a half. A half. Ladies and gentlemen, is a half. So negative 2 times a half is negative 1 plus 2 give us 1. It gives us 1. So therefore, g log E2, g log E2, and g log E2 give us 1. So this point also exists on g of x. So therefore, the coordinate of B is log E2 and 1. So to answer it, since the coordinate log E2/1 exists on both function, I would say. That must be the coordinate for point B. Right, since it says B is since in the question it says intersects at O and B. Well, it's not at O because it's not 0, 0. It must be B. All right. The second question: find the exact area of the region bounded by f of x and g of x. All right. So right now we have to find the area between the two. So you have to figure it out. You have to figure out which one is on top, which one's at the bottom. So first you have to figure out which one belongs to ex negative 1. Now ex negative 1 is actually this one. All right, this one. So ex negative ex to minus 1 is this. All right. So this one is in the bottom. Oops. Bottom. And therefore this is this one, which is the top. So this is ex minus 1, and the other one is something like that. That is negative 2 e to negative x plus 2. So we've got the top and bottom once we figure it out, and we just have to integrate. All right, so integrate top minus bottom with respect to the x, because they both got x's in it. And now, is this a definite integral or indefinite? Well, of course it's definite because we're finding out the area between the two graphs at a certain point. At which 2 point? So you've got two intercepts here, right? This point and, all right, let me use another color. So we're working, the 2 point will be this point and this point. Now this point, we just proved that it's got a coordinate of log E2 and 1. And this point is very, I mean, you know, this is the origin, that's where it begins, so it has a 0, 0. So this would be our x2, this would be our x1, right? So the domain for the integral would be log E2 to 0, all right? Okay, so let's just put the function in. Now remember which one's the top. The top one is the negative 2 one. Negative 2 e to negative x. Alright, so the negative 2 e to the negative x plus 2, I believe it was. And then minus to the bottom one, which is e to the power of x plus 1. Yes, I think it's plus 1, isn't it? Oh no, it's minus 1. It's minus 1 dx. Alright, let's just expand the brackets. So everything stay the same here. So negative 2e negative x plus 2 minus e to the power of x. Alright, and then plus this 1 dx. Alright, let's start integrating it. That should be easy. Now, when you integrate e to negative x, we can just put the negative 2 out first. When you integrate e to negative x, remember it doesn't change. And then we divide it by the derivative here, the derivative of this. And that would be negative 1. Okay, so plus this, now 2 just becomes 2x minus e to the, remember, doesn't change, and divided by the derivative here, which is just 1. And plus this 1x. And then log E2 and 0. That's it. Alright. Now I'm going to sub it in, just find out the definite integral. So it's negative 2 e to the negative log E2 all over negative 1. Or you can right now you can just say, negative cancel, and 2 divided by 1 is just 2. Alright, so you can literally just write, write 2e to the negative log E2. Alright, plus this 2 log E2 minus e to the power of log E2. Try to write the e better. Over 1 it's just that. So don't bother about that over 1 anymore. And plus this ln2. not ln, but you know, since I started with log e, so I just keep using log e. But they're the same. Log to the base of e is just log to the base of natural ln, not ln. Right? Where does this scale come out from ln? Okay, so it's log e2. Okie dokie. And then minus, we sub in 0 into wherever they were. So the first one is negative 2e to the negative 0 over negative 1, which is just 2. And then plus 2 times 0, which it will be 0, minus e to the power of 0 over 1, which is negative e to the 0. And then plus 1 times 0, which will be 0. Alright, let's tidy things up. So this would give us, now we know that this bit is give us half, right? By the you know, in question A. So it would be just 2 multiplied by half. Right? Pluses, now log pluses 2 lots of LONE2 minus e. Now e to the log e2, remember, is 2 from the previous question, plus ln2, log e2 minus, alright, now e to the power of 0, or anything to the power of 0, negative 0, 0, it's not negative 0, it's negative 1 times 0, it becomes 0. So e to the power of 0 is 1, so anything to the power of 0 is always 1, so it's just 2. 2 times 1 is just 2, plus is 0, minus 1 again, because e to the power of 0 is 1, plus is 0. So very easy on that side. Now this side is just 1, right? 2 times a half is 1, plus, now 2 lots of ln log e2 plus is 1 lot of le2 will give you 3 lots of l log e2 minus 2 minus 2 plus 4, 0 minus 1 is just 1, right? Now you can just leave the bracket, distribute this negative sign inside now. So just log 3 log e2 minus 2 minus 1. So it will give you 3 log e2. The 1 will cancel here with minus 2. So that would be the area between the two graphs. Alright, that's our answer there. Now, I mean, you can work it out. You can literally, you know, punch in the calculator and work out what's the real number, but I'll just keep it like this and, you know, just to keep it nice and tidy. And that's what the back of the book's, the answer anyway. I didn't look at the answer and put it here. I worked it out myself, okay? I didn't copy the answer, okay? This is fully worked out. Okay, so the last question, question C. Show that the sum of the area under f of x and g of x from x equal to 0 to x equal to log e2 is equal to the area of the rectangle OABC. Alright, so first I want to find out what the area of the rectangle OABC is, okay? So at this point, alright, so let's just swap it out for now. Swap those things before, so we can see it clearly. Alright, so the C has a coordinate of, it was that high, with 1 as the y coordinate, and 0 as the x coordinate. Alright, now B is what we worked out before, was log e2, 1, and O is 0, 0, and A is log e2, 0. Right, so let's just find out the area. So it's just length times width, or you know, whatever you put it. So the length is at log e2. Right, from here to here is log e2, and from here to here is 1. So just log e2 times 1. So this is log E2. So the area of the rectangle OABC is log E2 multiplied by 1 gives you log E2 unit square. I don't think it gives a unit, but still an area should have its unit. So let's just put it unit square there. Same as here, unit square. You know, it just doesn't feel right if it doesn't have a unit down, for me personally. All right, so we just have to prove the area under the curve f of x and under the curve g of x within the domain, between the domains x equal to 0 and x equal to log E2 is equal to that. All right. This is going to be tedious. Yeah, it's long time consuming, but it's all right. So let's just integrate each of them. So integrate ex minus 1, I believe. And our domain would be log E2 and 0. Let's do that. Find out so remember this is f of x. All right, so let's find out the area under that. So we get e to the x, when you integrate that is e to the x doesn't change, divided by 1, which is the integral of there, but you know, divided by 1, we just don't show it, which is the e to the x, minus x. Alright, and then it's 0 and log E2. Alright, let's just sub it in. So this is e to the log E2 minus log E2. Minus e to the power of 0 minus 0. Alright, e to the power of log E2 we know is 2 minus log E2 minus 1 minus 0. So it's just 2 minus log E2 minus 1. Therefore, 1 minus log E2 is the area. Alright, so remember the question say with the proof that the area under this curve and the area under that curve plus together give you log E2. Alright, let's just do for the other one. Same domain. Alright, so this is negative 2 e to the negative x plus is 2 with respect to x integrating. Let's just double check. Yep. Okay, so let's integrate that. So that will give us negative 2 e to the negative x doesn't change anything on the e doesn't change, the negative things on things that e to the power of 2 doesn't change, divided by the derivative of this, which is negative 1. Alright, and now that's 2 just cancel, and 2 to the power of 1 is just 2. So just 2 e to the negative x plus is 2x over the domain log E2 and 0. Alright, let's sub that in. So 2e negative ln2. Oh no, log E2 is same thing though, but you know, keep it consistent. Log E2 plus 2 log E2. Alright. And then minus 2e to the negative 0 plus 2 times 0. Right, so this part will give us, now we know that is half, so e to the power of negative log E2 is half, so 2 times a half is just 1, plus is 2 lots of log E2 minus, now 2 e to the power of 0 is 1 times 2 is 2, right? And 2 plus 0 is just 2. And once take away the brackets, so we get negative 1 plus 2 log E2. And then let's plus these two together. So AUC, area under curve, g of x plus AUC, area under the curve of f of x plus AUC g of x is equal to 1 minus log E2 plus negative 1 plus 2 log E2. Alright, now we know that the 1 and negative 1 cancel, and just to let you see better, let me rearrange the other two. So it's just 2 log E2 minus log E2. Now I'll just put let me just put the obvious one here, so obvious that then sometimes most of us overlooked. So it's 2 lots of LE2 minus 1 lot of LE2. So this give you LE2, and that is equal to that, right? So I forgot the unit square. Unit square, and voila, everything is done. So we just proved that it is the same. Oof, that is, look, that's not hard, but it's just, you have to be careful with all those integration and subbing the numbers and stuff. But it's definitely not hard, but you have to keep every step clear to yourself so you don't get the number wrong. Okie dokie, that's question 12. All right, let's head into a commercial break and come back with question 13, which will be the last one on chapter 8, 8E. Woohoo!